Welcome to a lesson with Dr. Pal. Let's look at an example of a partition. Let's take a collection of polynomials with coefficients in R, real numbers. So this is the collection of polynomials of any degree from 0 up, such as 2, that's a polynomial of degree 0, or 1 plus x cubed minus square root of 2 x to the fifth. This is also a polynomial with coefficients in R, real number coefficients, and the powers of x are non-negative. So these are just some examples. So let's partition polynomials here into some groups. Using this notation, we can describe polynomials of degree n in this way with real coefficients. Let's let that be that set. So in particular, we could write this set as all polynomials a naught plus a1x plus a2x squared all the way up to a n x to the n, such that a naught, a1, etc. to a n are all real numbers. Okay, so also we need another condition. For it to be degree n, it means that the leading coefficient can't be 0, so that actually the highest power is n. So really, this is degree n polynomials are ones where the leading term right here is non-zero, so we actually have x to the n in there. So we want a sub n not to be 0. So this would be the condition for this particular set. So for instance, P3R would include, so different elements of this set would be something like 1 plus 5x cubed would work. 2x minus x cubed would work. These are just various instances of things. However, x squared is not in here since its degree is not 3. Okay, so claim is that these guys partition this right here. And let's write down the notation for how to express that. Okay, so we know that P0, so degree 0, these guys, and we can use the disjoint union symbol to emphasize that, hey, things that are degree 0 are not degree 1, things that are degree 1 are not degree 0. They don't have any overlap because degree is unique, is well defined here for a particular polynomial. It can't be 2 degrees at once, it has to be just 1 degree. Okay, so we could do this and keep going. How far? Well, forever, right? Have to have up to degree n. So that's a lot of disjoint union symbols. If you think about it, like if you're having a sum of things, like if you had a sum of like b naught plus b1 plus b2 plus forever, right? Where the generic term is b sub n, you can express that with a notation like this, like n going from 0 to infinity, bn, and that would work for this sum. Similarly, we could do something here, but instead of using a summation symbol, in fact, what we should have used is, instead of summation, what we could have done is we could have just we could just made a big plus sign, right? That would have been maybe more intuitive, perhaps. But maybe we get confused that this might look like a coordinate axis or something. So we use a Greek letter there to represent sum. In our case, though, we can just borrow or use the symbol again. So what we do, notationally, we could just simply write the following. We could just write disjoint union and say n equals 0 up till infinity, and then just put PNR. And this represents the partition of the polynomials into with real coefficients into their various degrees. So we collected them into different degrees, and those don't have any overlaps. And so this disjoint union is equal to all of this. Now, we could have rewritten this disjoint union symbol simply as a union symbol. However, using the disjoint union symbol just emphasizes the fact that we're partitioning the polynomials into distinct pieces, and they have no overlap. Thanks for watching.